Hi, welcome back to LeetCode. So, in this video, I am going to discuss LeetCode problem 3593 minimum increments to equalize leaf paths. So, you are given an integer n, an undirected tree rooted at node 0, okay, with n nodes numbered from 0 to n minus 1. This is represented by a 2D array edges of length n minus 1. Her edges I represent ui, vi, indicates an edge from node ui to vi. Okay, each node I has an associated cost given by cost of I, representing the cost of to traverse that node. Okay, the score of a path is defined as the sum of the costs of all the nodes along the path. Our goal is to make the score of all route to leaf paths equalize by increasing the cost of any number of nodes by any non-negative amount. Okay, so we can't decrease. That means return the minimum number of nodes whose cost must be increased to make all route to leaf path score equals. Suppose for this example one, we actually have n is equal to 3. That means 3 node. So first is 0 and 1, then is 0 to 2. Correct. So what is the cost for this? For 0 cost is 2, and cost 1 for it is 1, and cost 2 the cost is 3. So for this leaf path, this is 0 to leaf path, means 0 to 1 leaf path. Another is 0 to 2 is another leaf path. So from 0 to 1 leaf path, the cost will be 2 plus 1, it is 3. So this leaf path from 0 to 2, the cost will be 2 plus 3, it is 5. So we have to make this actually equal. So we can't decrease the sum. So our target is to increase this cost of this path from 0 to 1. So, and also we have to ensure that we have to increase the minimum number of nodes. So that means if I actually increase in this node 0, is it possible to equalize? No, because if I add this, suppose x, I'm increasing here, so it will affect this path also, 0 to 1, and also it will affect the 0 to 2 path also. So that's why this is not possible. So if I have to actually equalize increase the path of 0 to 1, so if I increase the sum of the cost of node 1, so by what? By 2. So suppose it will, instead of 1, now it is actually 3. So what is the cost for now? 2 plus 3, it will be 5. Now it is equal, both are equal. 0 to 2, this is also 5, and 0 to 1, this is also 5. For this, the answer will be 1. I am modifying only one node. This is node number 1. So output y, this is 1. Got it? Next is this example 3, n is equal to 5 edges. These are the edges and the cost of the particular node, each node. So this actually our tree look like this, and for how many actually leaf path are possible? 0 to 4, 0 to 3, and 0 to 2. So for 0 to 4, the cost will be 3 plus 7, it is 10. So for 0 to 3, the cost is 3 plus 4 plus 1, it is actually 8. And for 0 to 2, the cost is 3 plus 4 plus 1, this is also 8. So our maximum path sum from root to leaf is 10. So we have to increase the sum or the cost of this path 0 to 3 and 0 to 2 to 10. So, or actually I can modify. So for 0 to 2, I can modify here, I can add plus 2 here, and for 0 to 3, I can plus 2 here. Here actually how many node actually I have to modify? I have to modify 2 node, correct? But if I actually modify the common node only, means here actually if I add plus 2, then actually ultimately actually it will modify the effect both the paths 0 and 2 and 0 to 3, both the paths. So in that situation I actually only need to modify only one node. So our answer will be 1, correct? Clear? So this situation also clear. And another situation something like this, this is actually 2, sorry, this is actually 2. So the cost for this path is, the leaf path actually is this, suppose x1, x2, x3, x4, x5. So cost for the one leaf path is x2, x1 to x2. So the cost for this actually it is 3 plus 7, it is 10. Another leaf path is x1 to x4. The cost for this is 3 plus 4 plus 1. This is actually 8. Another leaf path is x1 to x5. The cost will be 3 plus 4 plus 2. So this is actually 9. So, or actually I need to modify. I can modify here. Here I have to add plus 2, and also here I have to add plus 1. So for this situation I have to modify 2 nodes. So can actually modify here in this common node, because the path actually same. One path actually is here, another path actually it is, this is another path, correct? So I can actually, you can think that we can actually more update this here also. So what will be the amount I have to update? Suppose I for this path our sum was it is 8, so our target sum is 10, so I have to increase by 2. So if I increase here to plus 2, then what will be the sum for the x1 to x5? It will previously it was 9, and it will be increased by 2, it will be 11. So it is not possible to equalize all the path, correct? So that's why we have here for this situation, for this such situation we have to increase the individual node. Clear? So the what will be actually our target? Target is so this is such, suppose this is our tree. So first of all we will check that what will be actually the sum or the cost and the number of operation I have done for this subtree. Similarly for this subtree I will get that what is the cost, the path sum you can also tell that, and the number of operation I have done for this path. This is for path 1 and this is for path 2. Now for this what I have to do, I have to calculate the that how actually I can actually modify. I have to modify here individual node, in the child node, or in the current tree. So how actually I can modify in the current node, and also how actually I have to modify in the child node. So the situation is case 1 is modify current node. Okay, how actually I have to modify the current node. So for this example, you can actually go to this example, or how actually I'm modifying this node. How actually all the child subtree, the sum is same. Here also the cost is 1. Here also the cost is 1. Correct? Then only I do not need to modify here. Got it? I do not need to actually do the operation in the current node. So when all the cost for child subtree is equal, correct? This is to modify the current node. And case 2, to modify child node. When actually our the sum is different in another path. Suppose there are two paths. Another path is cost is C1, another is C2. So if C1 is different from C2, then one path I have to increase. So actually I have to modify. I have to modify this subtree. So that time I will only modify that this subtree by this cost. This cost it will be increased by suppose C2 minus C1, correct? And the number of operation will be plus 1. Got it? So if in bottom up manner, if I actually calculate this, suppose this is our subtree, our tree look like input array. So from here actually I actually passing that because this is actually leaf node. I do not know that do I need to apply any operation here actually or not. So that's why I return that cost will be same, the cost C1 and the number of operation I have done 0. Similarly for here cost is C2 suppose and 0. If C1 and C2 is equal, then do not modify in the subtree, in the child subtree. If C1 not equal to C2, I have to modify. Or actually modify if C1 is less than C2, then actually I have to modify here. Correct? So got it. And how many operation actually need? I need actually one operation. And if I modify this root node, if there is more suppose there is one more subtree, this will be also affected. Okay, it will be adjusted. So that's why I need to actually operation will be increased by 1. Operation plus plus. Clear? Or C2 is less than C1. Then actually I have to do the one operation. So if there are more it is possible that more than 2 child is possible, multiple. So this is possible that those mean actually subtree also I have to apply. So that will be increased for all the subtree. Suppose there is 4 subtree is possible. So I'll check that this actually equal to the target, the maximum sum. If it is not equal to, then I actually increase. I'll go to this subtree. If it is equal to the target sum, no. So then actually I will increase this operation. Otherwise I will not do the operation. But so if all the sum is same, then we don't need to apply. I'll just return from here that what is the I have done till now. The total sum will be total cost for this node. Suppose x plus c1 all actually equal now. Okay, and how many operation I have done? That will be the for this subtree I know that total operation plus for this root node how many operation I have done extra. So this will be total operation for this child subtree and for the current subtree also. This will be added and then returned from here. So ultimately what we are trying to do. So we are in bottom up fashion, we are trying to equalize from bottom to up. So that means first of all try to equalize here. Okay, then try to equalize here, and if possible to try to equalize here, something like this in this way. So what actually give us the minimum number of operation, because before modifying the child subtree I will check that can actually modify the current node or not. Correct. If here also the cost is C1, here also the cost is C1, but here actually our cost is suppose C2, here is C3. So that time I will modify only this node. I do not need to individually, I do not need to modify all the leaf node also. Correct. Clear? When C1 is not, C2 is not equal to C3, I will only modify this node because this is common to all subtree. So if I modify here, this will give us the minimum number of operations. Got it? So in bottom of fashion, I can easily actually find out the minimum number of operations I need, and also I can actually easily propagate the to the parent that how many operation I have done in the child subtree and what is the cost for this path. Right? So I need to pass two things. One is the cost for this path and how many actually operation I have done. Clear? Return this to the parent. Clear? Now go to the code. So first of all build the tree. So I have to make the adjacent node. So I am iterating the edges, and for u to v and also for v to u I am also storing this, and I am calling this helper function because they mentioned that the root is always 0 and the parent is -1, because this is not possible to go to child then again go to the parent. So that's why I need to know that which path actually I am coming to this current node, and also the adjacent nodes and cost of the particular node I have to pass this to know the what is the path cost for this particular path. And ultimately for answer I am returning two things. One is the what is the cost for this path and how many operations I have done. So in the second I am passing the how many actual operations I have done. So that's why I am actually passing the second value. This is actually pair actually. Okay. Now go to this helper function. I am getting one current node and the parent of this current node and the adjacent and the cost of each node. This is a vector of cost. So first of all I need to know that this actually the current node actually leaf node or not. So that's why I am taking a variable each leaf is equal to true, and I need to know the what is the child, like there are multiple child possible for each node. So I need to store that for each path, each child path, what is the cost and how many operation I have done. So I have taken two vector. One is for the path cost of this particular path, and what is the how many actual operation I have done. And I need to know that actually I need to know that all the path actually if it is same, the sum is same, cost is same, I do not need to apply any operation in the child subtree. Correct? So that's why I need to know what is the maximum sum. Okay. So and also the total number of operations I have done in the subtree. I have initialized 0. So I am iterating each child node for this current node u. So if this current node is equal to p, then continue, because go to the next. If it is going to the next, it is coming to line number 3, that means this is not a leaf node, it is false, because we have still some leaf node means there is no more, only we actually have some parent node only, there is no extra node, correct? So that's why this will be false now, and I will calling this the helper function again. I am passing the current v and the parent will be u, and similar way this will actually, it will store what this function will return the what is the cost for this subtree, like for v to the below the hierarchy of v, and what is the how much operation need to convert all the numbers equal in this particular path or the particular subtree. So in the current, I will store the current first, it will return the what is the cost of this particular path subtree, and also the how many operation I have done. I will store this in two different vector, first and second in the child sum and child count. So I need to know the what is the maximum path sum. So that's why I am storing into the maximum sum. Also the total count, how many operation I have done, because when it's passing into the previous or the parent to this current node, I need to pass that how many operation are in the below the hierarchy. So that's why I need to know the total number of operation I have done. So that's why I will add this. If it is leaf, the current node is leaf, that means we don't need to apply any operation now. It may possible in future, because in parent I found that okay, this is not equal, so I need to apply the operation in the child. So that's possible, but not now actually, because it may possible that only one node is possible. So that time it is leaf. So we will return that cost of the current path, because only one node is present, so cost will be the same, and the how many operation I have done here is 0. Else it is coming line number 25, that means it is a non-leaf node. So how many operation I need to do to make this subtree as equal, all the path actually equal. So that will be equal to, check that extra number of operation I have to do. So I'll check that the child sum, that means for each subtree I have stored in the child sum all the sum of the cost of all the subtrees, correct? So if our current sum is less than the maximum sum, that means this path actually not equal to the maximum sum. I want to equalize that. So then actually I need to apply the operation in the child subtree. So that why I will increase the number of operation will be increased by 1 extra plus plus. Got it? This situation is like something like this. So I actually have something like this. So in this path I got cost 1 C1, actually C2. So C1 is not equal to C2, and also suppose C1 is less than C2. So what I have to do? I have to apply the operation in this node, suppose plus X. So that's why, but currently I am here. So that's why actually I have to increase the extra plus plus. Got it? And why actually I am modifying this node only? Because it will actually affect all the subtree also below the hierarchy. Because I have already equalized all the path here till now. But to equalize this path, these two paths, I have to do an operation here only. Got it? Then only all the path till now it will be equal. So that's why I will do the operation extra plus plus, and ultimately after checking all the subtree, I know that how many operation we need to do in the child subtree. This will store in the extra, and in the total count what actually I have stored? I have stored that how many operation I have done in the below the hierarchy to equalize this. Something like currently suppose currently I am here, okay, and I already know that for this path cost is C1, for this path cost is C2. So actually I have written this. So suppose here actually suppose is C3 and C4. So I have done some operation here in this node. So that's why here actually operation will be 1. Then actually I got that here actually the cost is same as that, suppose C5, here also I got C5. Now here actually got C1, here actually I got C2. So C1 is not equal to C2. I have done some operation where here. So that actually I have stored in the extra variable, extra plus plus. Okay, but here actually I have done some operation in this node. But total number of operation I have done here actually 1, here actually 1. So total 2. So how shall I get this? I will know that okay, for this subtree, to equalize this subtree, I have done one operation. But to equalize this subtree only, I have done one more operation. So total it will be 1 plus 1. Got it? So I have to return this in a parent. So that's why I have to return the total cost will be cost of the current node, cost of u, and the maximum sum, because I have equalized all the subtree now. After this for loop, I have equalized all the subtree, and the current to go to the parent of u, I have to return the cost of u plus the maximum sum of the subtree, and also how many actual operation I have done to make the entire subtree equal, the path will equal, that will be total count plus the extra. Got it? So in this answer variable, I will get two things, only the total cost or the maximum cost of the path, and also the how many operation I have done in the entire graph. So in the second, I have written this second value. Got it? I hope this is clear. And if you found this video useful and helpful, and please like the video. If you are not subscribed, please subscribe channel. Thank you. Bye.